Hi, my name is John Spencer. You're at Gravitas in Strawberry Studios. Welcome to the NGF Quality Assurance System. NGF manufacture glass fibre cord, which their customers in turn use in diverse applications such as the manufacture of escalator handrails, timing chains in cars, and even, would you believe, makeup. The production process begins with molten glass and ends with the product departing the factory as cord wound onto bobbins, which look somewhat like giant cotton reels. These are packed into pallets at the warehouse prior to dispatch. The manufacturing process is controlled and monitored at every step by means of radio frequency identification, RFID. Every delivered bobbin also has an RFID tag attached, summarising the statistics from the batch or DOF to which it has a family relationship. This is a great bonus for the customer, particularly if the customer also has RFID equipment. Most products are manufactured to order. Customer order and dispatch information is managed by an Oracle-based database application named IFS. The quality assurance process. Quality assurance involves the selection of samples from each batch or DOF of product taken from different stages of the manufacturing process. Various tests are then undertaken to measure the properties, performance or limits of the sample with reference to product specifications managed within the system. Conclusions about the average capability of the batch or DOF to which the sample relates can then be drawn, leading to summaries which can both provide interactive control over the quality of the manufacture as well as accompany the dispatched delivery in the form of a quality certificate. Most samples are scanned when they're lifted from the production process. By feeding from the RFID database, these records form QC records against which the test results can be entered. Some products, called small products, are partially excluded from the RFID system, so get their QC records created by QA staff using the QA system prior to test entry. Some samples are returned to the production sequence, evolving into more mature products. Some test results are derived by the difference in the sample's properties at different stages throughout the production cycle. Technical orchestration. The QA server sits in the centre of the QA process. SQL Server agent processes regularly refresh replicas of both the RFID database as well as the Oracle IFS system. Refresh operations initiated by the QA or production operators bring in new QCs from RFID into the QA system and evolve identities of QC bobbins that have progressed further through production. Prior to packing, warehouse staff will have allocated RFID registered pallets in IFS against orders ready for dispatch. Subsequent refresh operations initiated by the warehouse operators or QA staff bring in customer order and dispatch details from the IFS replica. The operator can then instruct the QA systems to summarise relevant test results for the certificate to accompany the shipment. A SQL Server agent process regularly refreshes a replica of the QA system on the RFID SQL Server. To facilitate the collection of QA test statistics for writing into the RFID tag attached to each and every bobbin at packing. Flexibility. New tests can be added. Multiple translations of a single test can be created. Individual profiles representing cocktails of selected tests can be set up for later allocation to any product. Products arrive automatically from RFID but need their profile allocating and their specifications also need creating. Any customer can have their own cocktail of tests in their chosen order and chosen translation. So we set up a profile for this here. Unlike most bespoke software systems, the QA system allows the administrator to reconfigure the reports dynamically, thus future-proofing the company as their quality procedures develop. This amends the Access report design. Customers are allocated their reporting profile here. Also for reporting, a customer is able to have their own part numbers rather than the NGF product codes displayed on their reports. So, capabilities analysis. I have an interactive chart here. If I select a product of 841L2, I might look at its property of diameter and chart this. Interactively, I can set the chart minimum, as its minimum spec is on the floor. The dates range from JLA, which is the beginning of last year, up to KLG, so I might choose to keep this within 2009, and I can interactively type my own titles here. And I have a second chart for which I might choose the same product or a different product, but this time the same product, loss on ignition. Let's have a look at that property over the same period. We could do with a chart minimum of 16. All machines, all spindles, 12 batch codes in that selected, in our data set for that selected year, 23 samples within it, averages, standard deviations, CPK against specifications set. So, in conclusion, the arrival of this integrated quality system finally aligns data from throughout the organisation. It introduces integrity and control, and so forms a platform for all sorts of new management reporting. With every machine part, production item, order, test result and event recorded comprehensively, the possibilities for easy cross-reference to answer any question about the operation of the business are now limitless. Thank you for listening.